Hello everyone. In this video, we are going to talk about a concept called requester pooling settings in Pega. We'll first discuss theory about it, and then we will dive into some practical. So let's get started. Let me open any existing out-of-the-box service package rule. For example, this one. So this is a service package, and here in the pooling tab, we specify uh, the requester pooling settings. Whenever you create a service package, by default, Pega sets these values to uh, maximum idle requesters to 10, maximum active requesters to 10, and maximum wait in seconds to 10. So what does each of these mean? Let's start with maximum active requesters. Uh, so for this service package, maximum number of active requesters at any given time can be 10. It cannot be more than that. So let's say you create a service package. Uh, it's just created, and the very first request arrives, an active requester will be created. Uh, let's say 9 more requests arrives, then when the first one is already active, uh, at that same time, let's say 9 more requests arrives, then the total number of active requesters at that time would be 10. And if a next request arrives when all the 10 requests are active, the 11th request has to wait. So that is what is meant by maximum active requesters or active requesters. What are the what is meant by maximum idle requesters? So idle requester is nothing but whenever an active request is completed, it returns to the pool, which means it becomes idle. So uh, whenever a request is processing done, it will first return to the idle requester state, and if there is a new request, incoming request, then that idle requester would be converted to active requester. uh, so that way the number of idle requesters uh, should not be or cannot be more than the active requester. It can be either less or equal to active requesters. If you set it to more than active requesters, it doesn't add any value. So it has to be less than or equal to number of active requesters. And the maximum wait, let's say, for example, right now, let's say all the 10 requesters are active for this service package, and an 11th request arrives. That request has to wait. How much it will wait? It will wait for 10 seconds. That's the maximum wait. Let's say in these 10 seconds, if any of the active request becomes available, which means it becomes idle, which means it returns to the pool, then the 11th request will be allocated to that idle requester. If in 10 seconds none of the active request becomes idle, which means it doesn't return to the pool, then the 11th request will basically time out. So the consumer of your service will get a failure message, and then they have to, of course, retry or something like that. So this is the theory part of it. It might not be very clear at this moment. Let's do some practical. It might become a bit more clear. So let's get started. So what I'll do, I'll first create a service package. Let's do that. Let's say I'll name it, for example, I'll name it date time utils. Let's create a service in this package which is doing something with date times. Okay, fine. Just for example, so I named it date time utils. This is my service package. I'll give it an access group, my admin access group. Usually we can create a separate access group for services. Let's make it not require any authentication to keep it simple. So my service package is done basically. And you see, like I said, by default, it has Pega has already set the maximum idle requesters to 10, same with active requesters and the wait time. Fine, this is our service package. Uh, Let me create a service which will use this service package. Let's name it get current timestamps. Okay, and we will use the service package that we just created. Let's say version is v1, and here Yeah, we have to give something, right? Or maybe I'll put it like this. Utils. I'll just name it service 1. Doesn't matter the naming for now. Let's create it. So you see the URL is formed. It's called, yeah, datetime util. That's our service package. V1 is a version 1, and get current timestamp. That's the yeah, that is basically the URI template that we give. Okay. Uh, let's go to the methods tab. We will use the get method. So give an activity. Let's create an activity. Get. Let me create this activity. Okay. So here, let me do a property set. We are going to return the current timestamp, but let's create a basic data model first to return the timestamp. So I go here. This is my service class, the work class. I'm using the work class as my service class. Let me go to the data class. I'll create a property here. Okay, current timestamp, that's fine. It's a text property, that's good. Let's go to the work class, which is our service class, and here I'll create a page property. In order to use the property that we just created. Oh, sorry. That's my class, and the name of the property would be, oh, sorry, I messed it up. So it should be in the work class. Name of my property is, let's say, just page property. I'll create it. The type is single page, and here I'll give the data class so that it can access the uh, timestamp property, current timestamp property that we just created. Okay, let's go back to our activity. Here, then I'm setting on this page property in the current timestamp. I'll set the current timestamp. Let's format it a bit. So this should give us current date time, but I'll format it using an OOTB function. Here I need to give format. Let's say HH MMM. Oh no, sorry. So the time zone is Indian time zone, and here also the local IN English India. Let's just test it that it works. So for example, it's giving me, yeah, 185 on 30th of August. I think I missed it. It should be in small case. Okay, 113. So I can maybe make it 24 hours. So use capital H. Yeah, 13, 13, 24 on 30th of August 2025. So that's good. Let's save it. Let's save this activity. Let's go to our service. Here we have already given the activity name, but we need to return the response. So let's go to the response tab, and here we'll say map from JSON, and we will give the name of the page property, which has the timestamp as well. Let's save this. Okay, our service is ready. So I'll take this endpoint URL. I'll go to Postman to use as our API client. So here I'll paste the endpoint URL. I'll hit send. You see, we get the current timestamp. And this is fine. This is just the basics about the service and service rates. This just verifies that it's working. Now we need to see how the requester pooling things work. Okay. Uh, so yeah, one interesting thing. Now, if I, for example, we created this datetime util service package. If I go to Admin Studio, uh, on the landing page of Admin Studio, here under requester pools, we should see our service package. We do. You see, datetime utils, and here we see At this point in time, it has 0 active requesters. It has 1 idle requester. Uh, Longest wait is 0 and timeouts are 0. So let's try to play with our requester pooling settings and see how things changes here. Okay. Uh, so basically, right now what we see here, one, what does this mean? We sent one request to this service, right? Just a few seconds back. So at that moment, an active requester was created, which means at that moment, active would be 1. After that request was complete, that request has returned to the idle state. And that's why we see 1 here. Of course, it is not very clear right now. That's why I'm saying let's play with the pooling settings, and then it will become a bit more clear. So what I'll do, I'll go to the pooling tab. Let's make number of active requester just 1, and also number of idle requesters to 1. Like I said, idle requesters should be less than or equal to active requesters. If it is more, it doesn't make any sense. Okay, now I have set it to 1 and 1. And let's go to our activity, the service activity, which is this. So here we are just setting the current timestamp, and this operation of getting the current timestamp and putting it in a certain format is very fast. It doesn't take, yeah, it hardly takes few milliseconds. So let's uh, make our service activity wait a little bit explicitly by specifying wait. So let's make it wait for 5 seconds. Okay. So every time a service request comes, our service activity will start. It will first wait for 5 seconds, then it will generate the current timestamp, and then it will return. So basically, our service activity will take 5 seconds plus few more milliseconds. Uh, why I do it? It will be clear uh, in a bit. Let's go to Postman. You see, earlier the response was received in just 75 milliseconds. Now we have added an explicit wait. What that will mean is the response will come after 5 seconds. At least it will take at least 5 seconds. So let's verify that first. You see, it's waiting. It's taking some time because of that wait. Okay, it took 5.08 seconds, and the response was received. So now I'll create another tab. Okay, I'll copy our same endpoint URL, put it here. If you remember, we have set our number of active requesters to 1. So there can be only one active requester at any given time. And I have now two different tabs. So what I'll do, I'll start or send the request from here, and immediately I'll send the request from the second tab. That way, what will happen is first requester, uh, that will be served. It will take 5 seconds, and the second requester, it will take 5 seconds from the time first requester was completed. So let's see that in action. So I'll send this one and this one. So now see, you both the requests are waiting. So first one is completed in 5 seconds. Second one is still waiting because it started after the first one was completed. And you see, it took 8.39 seconds. Yeah, basically the difference, it should be 10, but because I had to switch tabs and click on send, that took 1.5 seconds. That way, it took 8.39 seconds. So you see, uh, based on our settings, so because we set maximum number of active requesters to 1, the second request had to wait before the first request is completed, and then only it started processing the second request. Now we can see this in our admin studio as well. Let's to make it a bit more clear, I'll increase the wait time in our activity to 10 seconds. Okay, I'll also go to admin studio, to the landing page, to the requester pool. Again, here right now it is just one idle requester, nothing. You see, yeah, basically we also see longest wait is 3 seconds, because when I sent the second request, it had to wait for the first requester to become idle, and that's the wait we see here. So we are already seeing this in action. Okay. Uh, Now let's go to Postman. Again, send the request. So we have made the wait time in our activity to 10 seconds. Uh, so let me send this, and let me send this, and let me refresh here. So you see, currently one requester is active. So there is no idle, right? One is active. I'll refresh. Still one is active. Okay, uh, because most likely the second one has started now, and you see the longest wait has also increased because the second request took required 8 seconds to be started. Yeah, if I refresh this now, yeah, you see both the requests are processed and the active requester became the idle requester. And we can see that here too. You see, first request took 10 seconds, second one required 18.74 seconds because it had to wait for 8.5 seconds before it could be picked up. Okay, so this is how the requesters work. Now maybe the third setting in the requester pool, uh, which is which is the maximum wait. Okay, so what does this signify is any incoming request uh, would be kept in a waiting state for maximum 10 seconds because we have specified 10 here. And if in 10 seconds and requester doesn't become available or idle, that request would be terminated. So we can see that also. Let's make it, I'll make it 5. Okay, I'll save this. So what I have done, so we have there can be only one active requester at any time. There would be just one idle requester at any time, and the maximum that an incoming request will wait is 5 seconds. If in 5 seconds an active requester doesn't become available, we as in Pega, the platform will reject the request, and the consumer or the client, in this case postman, will see a failure message. Okay, and if you remember in our activity our wait is 10 seconds, which means if we send two requests at the same time, the second request should see a failure because the uh, service activity is taking 10 seconds to process, whereas the wait time is set to 5 seconds. Okay, so I send first, I send second. This second request will time out. We should see a timeout. You see, yeah, it failed, right? 500 internal server error, which means Pega rejected this request because after 5 seconds, which we see here as well, requester wasn't available. So it basically rejected the request. Now it is up to the client what they want to do with such a failure. And the first one would be succeeded in 10 seconds. Yeah. And if I go to admin studio, we will see that here as well. If I go to requester pools, you see there's one timeout. Okay, that's the timeout which just happened. Earlier it was 0, now it's 1 because we rejected or Pega rejected a request. Basically it timed out. We can also see that we should see an error in our logs. So let's go there, log files. If I go to the log file, let's remove this, and if I go to the recent lines, we should see a timeout which is or some error or failure. I believe it's this one. Let's scroll up. Yeah, you see, timed out borrowing service requester from requester pool for service package. Timeout set to 500 seconds, which means a timeout happened. We also see problem obtaining requester from the service requester pool. Yeah, basically what we have set in the setting, it's working. Okay, uh, let's maybe do a little bit more here. If I go to the service package, let's make it 2 active requesters. So if I make it 2, so at any given time, there can be 2 active requesters, even if the wait time is maximum wait is set to 5 seconds, whereas our activity is taking 10 seconds. Even then, the second request will not fail because at any given time, there can be 2 active requesters now, not just one. So let's go to Admin Studio. Let's go to Requester Pools. Because I changed the setting, it disappeared from here. But let's go and send 2 requests, and then I'll refresh, and then we should see 2 active requesters. Okay, I'll send this, I'll send this, and if I refresh, you see there are 2 active requests at this time. If I refresh, keep refreshing, uh, there's one active, one idle right now. First one finished, second one might have finished right now. So let's refresh. You see, yeah. So there's no active, but there's one idle because we have set idle to just one. It could have been set to 2 as well. That way, too active would become too idle, but we have set it to just one, and there is no wait, there is no timeout because we changed our settings that way. Okay. uh, what else? So yeah, other things. So this is how we have seen it in practice. uh, and I mean the significance of it, we have already seen the significance of it, and we can use it or leverage it for our use cases, whatever our use cases are for um, our application, whatever we are working on. So we can work on that. I can even show an a practical example of this in action. If you like, maybe let me know in comments, and then I'll make a second video about this. uh, and yeah, in general, why this is of significance is every requester takes system resources, it takes memory, so we should be very careful with it. We should yeah, usually just 10 and 10 the default values will work, but it's good to know about these. Let's say you are facing some performance issues, then maybe you can tune these settings if needed. And like I said, system resources are limited, so you have to use it wisely, not just for services, but in general, right? For background processing and every single thing that we do. But yeah, these are the things about the pooling settings. Let me know if you have any questions, or if you want a part two with, I can show exactly uh, where we can use, like maybe with a use case, an exact use case that could be simple. So I can make a video about that. But for now, that's it. Thank you very much for watching.